Welcome to this video on solving a numerical problem involving the vapor-liquid equilibrium constant, specifically tailored for JEE advanced preparation. In this problem, we examine a non-ideal binary solution of two components. We need to derive an expression for the total pressure at the azeotropic point, and then calculate that pressure using the provided values for activity coefficients and pure vapor pressures at a constant composition. To solve this, we first define our core terms. Vapor-liquid equilibrium describes the balance between liquid and vapor phases. At the azeotropic point, the liquid and vapor compositions are identical, meaning the ratio of vapor mole fraction to liquid mole fraction equals 1. Using the equilibrium relationship for component 1, we can simplify the expression for total pressure. By substituting the azeotropic condition, where the composition ratio is 1, the equation for total pressure becomes the product of the activity coefficient and the pure vapor pressure of the component. We can verify this consistency with component 2. At the azeotropic point, the product of the activity coefficient and pure vapor pressure must be the same for both components, confirming our derivation. Now let's calculate the total system pressure. By substituting our given values for component 1, we get a pressure of 300 kilopascals. Checking this against component 2 confirms our result as the system is in balance. In summary, the total pressure of the system at the azeotropic point is 300 kilopascals. Remember, at this point, vapor-liquid equilibrium constants simplify to 1, and the total pressure is simply the product of the activity coefficient and the vapor pressure of a single component.